Hi, this is Prof. Rassi. Welcome to this video on introductions to exponential functions. I'm recording at home today, so if you hear any noises in the background, it's just my kids playing downstairs. This section looks at exponential functions. In general, mathematicians are interested in how things change. Exponential functions can be shown in a variety of situations. Today I'm going to look at the coronavirus. This is a graph of the coronavirus and how it increased in the U.S. from January 22nd to March 13th. You see right here from March 1st to March 13th this really sharp increase that happens really quickly. And that's what we refer to as exponential growth. Mathematicians are definitely interested in how things change, and when things change quickly, we call that exponential growth. We'll take a look at an article from the Washington Post. Here they're going to use a simulation. They're going to use these little circles to represent people. And a healthy person is a gray dot, and a sick person is a brown dot. And in this simulation, whenever a brown dot or a sick person comes in contact with a healthy person, they will infect that person and their dot will turn brown. So take a look here, just like this. You see the brown dot infects the gray dot, which turns it brown, which then in turn infects other people. So this is the simulation. But people don't only get sick, they also recover. So in this next little slide, you can see how people get sick, but then after a while they turn purple, indicating that they are now recovered and are no longer transmitting the disease. Here is an example of 200 healthy people and one sick person. And watch as the sick person infects the healthy people, and notice how quickly the graph changes from gray to brown. And then you'll start to see a few people getting well, and quickly they will all turn well. This process is a change in exponentially. The people are getting sick at an exponential rate. So let's take a look back at the notes. We've studied in this class linear change, and that's a place where for each time, each day, each minute, whatever it is that you go over, there's a constant increase. So maybe it increases by 2. So I go over 1, up 2, over 1, up 2. Or in this graph, it looks like I'm going more over 1 and up 1. But each time, there's an increase consistently. That's linear change. We then looked at quadratic, or parabolas. Quadratic change has a U-shaped graph. And there we see that you go over 1, it increases a little bit. But if you go over 1 more unit, it increases even more. Go over 1 more, we even get a greater increase. Go over 1 more, and we see that we get a really large increase here. And so here we have a similar setup where there's an increase in growth, but not as fast as exponential. Exponential starts out slow, over 1, up, maybe 1. But if we go over 1 more, we could see this curve. It just really shoots up, and it's hard to even draw because it's off the graph. And so this is an exponential growth.